Hi everyone and welcome. Today we're going to be going over our first half of Unit 3 review video. So again, looking through those first four sections, really focusing more on addition, subtraction, multiplication, and factoring of polynomials as opposed to when we were doing a lot of our radical and root operations to finish up the unit. So a good review of things from weeks past, some good practice skills here, and like I said at the end of the last video, if you're looking for more practice problems, please go to CK12. Again, optional on CK12, but some extra practice problems will definitely put you in a good position to be successful on your quiz. All right, so first things first, evaluating whether or not things are polynomials. Remember, a couple of rules about polynomials. Number one, no radicals allowed. So if you see this, not a polynomial. Secondly, no fractional exponents allowed. So you see fractions on those exponents, again, can't have them. Finally, number three, we cannot have any exponents in our denominators. So if you ever see, not exponent, a variable. If you ever see a variable in the denominator or you see a negative exponent, which is the same thing as having a variable in the denominator, neither of those things are allowed. Be ready for those first two questions on your final assessment here. We'll be asking you, true, false, are these or are these not polynomials? Hopefully this information here will help you with A and B, some good practice there. And to review, again, I see a radical here, so that looks like it's going to disqualify this one from being a polynomial, so not a polynomial. Secondly, in order of degree. So we want to put these things in order of how many variables do we see. So this one has x to the third, so that's third degree. X to the second is second degree. There are no variables with 4, so it is to the 0 degree. And our first one has a single x, so that's to the first degree. So putting this in order, x cubed, 3x squared, minus 6x, minus 4. All right, operations on polynomials. On our last quiz, this was the most challenging question for many of us here, so be careful. This is an addition sign. This is not a multiplication problem. There is no box method needed for this. We are simply looking for what are our like terms. X squared and x squared, those are like terms. We can put those together. If we have just x and just x, again, those are like terms. We can put them together. And then finally, if we have constants, again, like terms, we can put those together. So 3x squared minus 6x squared. It looks like that is going to give us a final answer of negative 3x squared. Our minus 4x and our minus x get us negative 5x's. And here, positive 4 and positive 1 get us 5. And we can't forget about our little x to the third power there. No like terms for it, so it does not change. Same idea for the bottom one. The only difference is please make sure you distribute this negative to each of these numbers. If you do that, you're going to be in good shape, match up those like terms, and we will be 100% successful on these questions. So again, addition and subtraction mean no box method, like terms only. All right, team, moving on to our next set of questions, some review of division. Synthetic or long division is your choice. We focus mostly on synthetic in class because the organization is a little bit easier for us here. A reminder, this is a trick question on part A. We cannot skip degrees. We go from a third degree here to the third power to a first degree. Can't do that. We need to rewrite this question as x to the third power, 0x squared minus 4x plus 6. Again, can't skip degrees, got to put our second degree in there. There is no second degree, so we put it in 0. Now we are dividing by x minus 1. So we got to set this up. In our box goes the opposite. What we see here, that's a minus 1, so we put a positive 1. And then now we can list our leading coefficients of each of these numbers. So 1, 0, negative 4, and 6. Now that we have this, we can begin our operations on synthetic division. Bring the first number down, multiply it by the number in the box. Just gives us a 1. Add these two together. 0 plus 1 gives us 1. Again, multiply that by the number in the box. Again, gives us 1. We're left with a negative 3 here. Negative 4 plus 1 gets us negative 3. Again, multiply that by positive 1. Gets us a negative 3. Leaves us with an answer of 3 here. Term by term, we start with our remainder over x minus 1. Again, always over what we divide by. Next is our 0 degree, followed by our first, then our second degree term. So first degree is one variable. Second degree is the variable squared. Final answer. Put all those things together with that remainder, with those variables and degrees in there correctly, and we will be 100% on our way to where we need to go. All right, some final examples here with factoring. Our first one, box method. First and last, we know that every single time first and last term go in our first and last box. It's now our job to break this 40 down into all of its factors. So we have things like 40 and 1. We have things like, I don't know, 20 and 2. We also have 10 and 4. And let's just pause there. Once we are here, we take whatever this sign is, and we can subtract for each of those. We'll get 39, we'll get 18, we'll get 6, and 6 is our match. We're looking for that as our center term. So we know on the outside, we're going to be using 10, and we're going to be using 4. We know our top corner is x and x. Now the challenge is, what signs should we use? 10 and 4 together get positive 14. We're looking for negative 6. Maybe let's try putting a negative sign here. When we do that, negative 10 and positive 4 get us negative 6, and this is the answer that we're looking for. So our final answer to this is not the box, not anything other than writing out the sides of our box. Again, when we do that, we'll get our final answer. Please do that for this next box as well. Again, set up a box with that first and last term. And before we do, recognize that our GCF is 8. We can take an 8 out of both of these, so we'll have 8x squared minus 4. Once we do this, now we can factor that as a box. So be careful, be ready to identify those GCFs. All right, team, as always, any questions, please let me know. Again, extra practice questions are located in CK12 for, again, your growth and for any review that you need. Again, feel free to message over